Hello and welcome to the section 7.2 lecture today. Today we're going to be talking about reflection transformations. So before we talked about translations, which was just moving something in a certain direction, today we're going to talk about a reflection, the same way that you would talk about a reflection like in the mirror. Okay, some key elements, and again, we're looking both algebraically and geometrically at these. But a couple of the key elements are when you reflect something across a line, you are moving that point the same distance that it takes you to get to the line, you're moving it the same distance away from that line and in a perpendicular direction. Okay, so that's more of the geometric side of it. Algebraically, it's not too bad. When we want to reflect a point, now, this is kind of difficult because of the verbiage here, but sometimes you'll hear things talk about reflection in the x-axis, which seems weird. But if you think about looking at reflection in the mirror, that's what they mean by that. And then other times you'll hear them talk about the reflection across the x-axis. And those two things mean the same thing. And same thing, obviously, with y-axis and whether it's in or across, it means the same thing. So coordinate-wise, all we do is if we want to reflect it across the x-axis, all we want to do is change the y-coordinate to be negative, or its opposite. It's not always going to be make it negative. It's not just going to be make it negative, but it's the opposite of the y-coordinate. And the beauty is for reflection in the y-axis, I'm changing the x-coordinate, and I'm doing the same thing. I'm writing down the opposite of the x-coordinate. And the way that they say it here is that they say multiply the y-coordinate by -1, multiply the x-coordinate by -1. Okay, but those are the reflections that we're going to look at today, is the x-axis and y-axis. And granted, we could reflect things around any line. Okay, we could. We tend to stick to kind of a little more of the basics as much as we can, but it would be possible to, if you wanted to reflect something across this line, well, let's hope for somewhat of a straight line there. Still not that straight, but you could do it across that line also, and it's not that bad. So I do want to look at a couple different ways of sort of figuring this out. I want to come up with a way that we can do it using coordinates, and a way that we can do it using just kind of a visual observation. So this first one, we want to reflect it across the x-axis. So I'm going to take Q here, and it's 3 units away from the x-axis. So I'm going to move 3 units on the other side of the x-axis and put its corresponding point Q prime. R is 1, 2, 3, 4, 5 units away. So R prime is going to move 5 units away in the same direction. That's going to be R prime. And then S prime is another 3 units away. So 3 units to here. And that's going to be, it doesn't look like an S. That's going to be S prime. And so we'd get our new shape right here. And we can see how the orientation sort of changes when we talk about a reflection. I'm trying to get that other line out of there as good as I can without redoing everything. But we can see how a reflection is going to change the orientation of the figure, right? It doesn't look the same anymore, but it's just flipped over. Okay. Next one, another reflection across the x-axis. The other way that we can look at that is just like what it says up here, is we can look at the coordinates. And if I think of the point F being on 0, 4, and I want to reflect it across the x-axis, which this box is all about, I'm switching the y-coordinate. So it's going to turn into 0, -4. So if you can do that, and sorry, that's going to be F prime. If you can do that, there's never any reason for having to draw any lines, counting any units, because you kind of already did it. G is here at negative 2, 5. So G prime is going to be at negative 2, negative 5. And that's going to be G prime. It's going to be right where I'm going to draw that side. So maybe that's not the best spot for it. Negative 2, negative 5. Sweet. That's right there. If we look over here, let's go with H. H is at negative 5, 4. I love that I can say it but not write it. That's always fun. Negative 5, 4. And so H prime is going to be at negative 5, negative 4. Because all I'm doing is switching the y coordinate. So H prime. And then I prime at negative 5, positive 2 is going to go to negative 5, negative 2. And that's where I prime will live. So then we've got those 4 points. Again, try to graph them as good as you can. Do your best at making straight lines. All right, let's look at the next one. I have a reflection across the x-axis. Maybe I look at more graphically this time. T is going to move to right here. R moves 3, so we move 3. And I guess I need to label these. I do expect labels on all of yours. And then S is going to end up all the way over here. S prime, I should say. And there we go. Now, when we reflect across the y-axis, which we can do, it's just the opposite, and that was the other part of the rules up there, is reflecting across the y-axis. It's just changing the sign of the x-coordinate. So L is going to move from where it is to right here. L prime, because its coordinates were negative 1, 2. And when I switch the sign on the x-coordinate, that turns into 1, 2. Okay, it doesn't always mean make it negative. It means have the opposite have the opposite value, opposite positive or negative. K goes from negative 4, 3 to positive 4, 3. Not too bad. J goes from negative 4, 2 to positive 4, 2. I guess that's K prime. That's J prime. And M is going to go from negative 3, 0 to positive 3, 0. Right about there. Okay, I'm not seeing any on these ones, but if we were to reflect this across the x-axis, just as an example, where would M go? So if instead I reflected it across this line, where would M move to? Okay, and I bring this up because it doesn't really happen in any of these problems, but it is important. Turns out that M's not going to move anywhere. M and M prime would have the same values if I was reflecting it across the x-axis. That's like the idea of having a mirror and looking at the reflection, but then touching the mirror, right? Those two fingers that you touch the mirror with are at the same point, so there is no movement. Okay, I just bring that up because it doesn't come up in any of these ones, but it is something that can come up. So let's move on. We'll get these two done pretty quick. X is going to move from here. It's at negative 4, negative 1 to positive 4, negative 1. X prime. W is at negative 4, positive 3. So positive 4, positive 3. So that's W prime. And then V prime is going to move from negative 2, positive 3 to 2, positive 3. V prime right there. Okay. Now on this last one, something weird does happen. Something that we haven't really seen yet does actually happen over here. I want to reflect this across the y-axis. Okay, but I have points in the shape that are on each side of the y-axis. So that's kind of weird to think about. We don't really have that scenario happen with a mirror. That's not something that can happen for us. So that is a little bit different. But we just follow the same rules. Y is 4 units away from the y-axis, so it's going to move 4 units on the other side. Same thing with z. It's 4 units away, so move it 4 units away. Sorry, that is y prime, that is z prime. And then x is 1 unit away this way, so move another unit away, and x prime would be right there. Let me try to get rid of some of those other lines that we don't really need, just to clean it up a little bit. But we see here that the reflection of this, even though it's got points on both sides of the y-axis, we still follow the same rules, and it's totally okay. All right? Anyways, I hope some of that made sense. We were able to get some of that down. If you do have any questions, make sure you write them over there on the left. Otherwise, I hope you have a great day, and we will see you in class.